All right, hey guys, so we're looking at equations in two variables notes. So a solution of an equation in two variables is any combination or ordered pair, x, y, that makes the equation true. So when given the equation and coordinates, you can substitute numbers in for x and y in order to determine if they are solutions. So if we're looking at our examples, we've got 3x minus 4y plus 8 equals 2. Now, what it means when we say substitute is we've got ordered pairs here, 2 and negative 3. So what I can do is I can say, okay, 3 times 2 minus 4 times negative 3 plus 8. I need to see, does it actually equal 2? So 3 times 2 is 6. 4 times negative 3 is 12. So we got minus negative 12, which is actually plus 12, plus 8. 6 plus 12 is 18, plus 8 is 18, plus 6 is 24, 27, 20, 26. Is that 2? No. So that one doesn't work. So what I'm doing each time is I'm plugging numbers in. I am also making sure I follow order of operations. So I made sure to multiply both before I ever did any addition. All right, again, I can do 3 times 2 minus 4 times 3 plus 8. 3 times 2 is 6 minus 12 plus 8. 6 minus 12 is negative 6 plus 8 is 2, which means that this one works. Now, just because we found one does not mean that there could not be another ordered pair that works as well. So we have to make sure to try all of them. So I'm going to do 3 times 4 minus 4 times negative 5 plus 8. 3 times 4 is 12 minus negative 20 plus 8. This becomes plus 12 plus 20. We're already way above 2, so we know this one doesn't work either. Meaning, the only list they gave us is that works is 2, 3. All right, same thing down here. Now, I need to make sure that I'm following order of operations. So I've got 2 times 3 plus negative 2 minus 3 times negative 2. And I need to see if it actually equals 9. So 3 plus negative 2 is going to be 1. 2 times 1. 2 times 1 is 2. 3 times negative 2 is negative 6. So we have 2 plus 6 is 8, not 9. So this one doesn't work. All right, you're doing the same thing on each one. Go ahead and see if you can try it on your own and see about negative 2 and 3 and 4 and negative 1 and tell me if they work or not. I'm going to pause this, give you a second to try that. You're going to pause and then check your answers. So once you've plugged all those numbers in, you should find that negative 2, 3 gives you a negative 7. So it does not work, but 4, negative 1 does work because your end result is a positive 9, just like over here. All right, another example of this equation in two variables is that you could be given an equation in which you need to create a table and a graph. So in this case, it gives you the, Mark wants to have a laser tag party. The cost of the party, y, can be modeled by the equation y equals 20x plus 15, where x is the number of guests. We need to complete the following table and plot the points on the graph. So over here, it tells us that they've got 3, 5, 7, and 8. So we're going to take that 3 and plug it in for x. So in other words, this is going to be 20 times 3 plus 15. So our coordinate is 3 for x, but then 20 times 3 is 60. 60 plus 15 is 75. So this is 3, 75. All right, 20 times 5 plus 15. 5 is our x-coordinate. 20 times 5 is 100, plus 15 gives us 115. That is our y coordinate. All right, so each time I'm plugging in the x values to find my y values, because y is equal to 20 times our x value plus 15. Okay, 20 times 7 plus 15. Well, 20 times 5 is 100, which means that this would be 140, plus 15 would be 155. So this is 7, 155. And last but not least, 20 times 8, that's 160, plus 15 would be 8, 175. All right, in order to plot this on the table, we need our x coordinates along the x along the x line, and then a y coordinates along the line y. So we have 3, 5, 7, and 8. And over here we got 75, 115, 155, and 175. 3 goes to 75, 5 goes to 115, 7 to 155, and 8 to 175. Then in order to make this official, we take something with a straight edge and we draw a line through all 4 points. All right, let's flip over to the back. All right, so this one is just another example of what we just did. It's got a graph already labeled out for you, so it's a little bit easier. The important part here is that you get to choose your x's. You can choose any x values you want. You could even choose 1. So, in other words, you'd fill this out as 2 times 1 minus 5. So 2 minus 5 is going to be negative 3. So your coordinates are 1, negative 3. And you would come over here and you would plot it on your graph. And make sure you draw that line through the end. I wanted to look at the second one here because it's a little different. Rather than having y on one side, y is on the same side as x. So we need to move x away from y in order to make sure that it's y equal to whatever's happening to x. So just like we used to do with our equations, we're going to do the opposite in order to move x. So this is subtracting x. We're going to do the opposite, so we're going to add x to both sides. So now our equation actually is y is equal to negative 3 plus x. Now you can choose all of your numbers. I'm going to put 2. So in other words, negative 3 plus 2. Well, negative 3 plus 2 is negative 1. So my coordinates are 2, negative 1. I come over here, 2, negative 1. And I put it on my graph. All right. So each of these has 4 spaces. I want you to go through and fill out these top 2 here and go through and fill out as many as you can, as any numbers you want. You could do anything from 0 to whatever. Just make sure that you can solve it and solve it correctly. I'm going to pause this, you pause it, you finish it, and then check your answers. All right, so I tried to keep it simple and just go 1, 2, 3, 4, which gave me, I rewrote it every single time, which gave me 2, negative 1, 3, 1, 4, 3. So when I draw this, my line should be moving in a steep upwards direction, going towards the right. All right. Same thing down here. I had 2, negative 1, then I got 3, 0, 4, 1, and 5, 2. You could have made your numbers a lot further apart, but your line should still look very similar to what I've got right here. All right. If you want more practice, you can do the next one, but I believe you guys are all set to move on to your homework. Good luck, and I hope to see you soon. Bye, y'all.